Okay, we're going to be looking at equivalent fractions, and I'm going to practice or show you two ways that we know if two fractions are equivalent. So one is with models, and then one is using our strategy where we multiply or divide. Now, to know if a fraction is equal, you can multiply the top and bottom by the same number, the numerator and denominator by the same number, and you should get the number over here. If you don't, then those are not equivalent, and it can go both ways. So I can divide from here to here because the numbers are going smaller, or I can multiply from here to here. Either way is going to give you the same response. So I can do 2 times 4 is 8. Now whatever I do to the bottom, I must do to the top. Okay, so if I do times 4 here, I have to do times 4 here. So 2 times 4 is 8. Is 1 times 4 4? Yes, so that means that these are equivalent. Now, to justify my response, I can use models to justify that is correct. So I can use, one way is to use a fraction circle. So 4/8 and 1/2. So I'm gonna put 1/2 here, here's 1/2. And then 4/8, let's get 4/8 over here. And if I put it directly on top, I can see that those are equivalent fractions, because fractions are equivalent if they represent the same portion of the same size whole. And these represent the same portion or the part or the piece. I can see that 4/8 is equal to 1/2. Okay, another way would be to use a number line. Okay, so I can use a number line. I'm going to represent 4/8 here and 1/2 here. Okay, so here's 4/8. I'm going to do 4/8 here. I'm going to divide this into 8 equal parts. So that would be 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8. And the bottom one is going to be 1/2. Okay, so there I can see that they are equivalent. Now remember, when comparing fractions using models, they have to be the same whole. When using number lines, the number lines have to start in the exact same position, the same spot, to make sure that those are equal. If they fall on the same part of the number line, they are equivalent. And here you can even draw a line to prove that those are equal because they fall on the same part. Another way would be to use fraction strips. Okay, so I can draw my fraction strips here. I'm going to do 4/8 here and 1/2 here. Okay, so that would be 4/8 there and then 1/2. And then I would color those in. 2, 3, 4, and then 1/2. And those are equal. Let's do one more example. 1/2 and 5/12. This time I'm going to do the model first. 1/2 here and then 5/12 here. So here's 1/2, and then I have to do 12 equal parts there. Okay, so I have to do 1, 2, 3, 4, 5 to make 6 parts. 1, 2, 3, 4, 5, 6, and then 5 more lines over here. 1, 2, 3, 4, 5, 6, and then I'm going to shade in 1/2, and then 5 parts to show 5/12 on the bottom. 1, 2, 3, 4, 1, 2, 3, 4, 5. So here, this shows that these are not equivalent fractions. They're not equal, because this model shows that 1/2 is greater. So it would be the symbol 1/2 is greater than 5/12. Let's go on and do, let's do a fraction circle to show, and this time it was 1/2 and 5/12. Okay, so let's do 1/2 and 5/12. So 1/2, my 1/2 circle is here, and here is 5/12. It's in black, but there are there's 5 pieces there. Okay, and this shows that 1/2 is greater. So our symbol should be like that. Those are not equivalent. So going back to our original, now we're going to use a strategy where we multiply. Okay, 2 times what number is 12? 2 times 6 is 12. Whatever I do to the bottom, I have to do to the top. Is 1 times 6 5? No. Okay, so that tells me that those are not equivalent because 1/2 is greater than 5/12. And I justified that using our strategy with multiplication and with models. Okay, so those are equivalent fractions. Always remember that this prefix right here, equivalent, that means equal. Okay, see you guys later.